So now I'm going to lay out the steps that I'm going to try and follow to make a cast iron lap nut. One of the ways people do thread lapping sometimes is they might just take a nut that's already the right size, cut it once in the bandsaw, and then just put it in a vise and screw the object that you need to clean up the threads through that nut. Use some lapping compound, choose your flavor, and if you tighten the vise, it grabs tighter, and you can use that to create this abrasive force to clean up your threads. The nice thing about using a nut is it's already made, it's already the right thread, it's already the right size, it's got some external surfaces that you can grab for easy turning, and it's got external surfaces that you can squeeze so that you can change the internal diameter and make it clamp your threads more. So I want to do all of those things, but do it in a slightly more precise way. And so my project, what I have here is I sliced off a 1-inch length of a 3-inch hot rolled cast iron bar that another student had acquired. And I've got three phases. So phase 1 is going to be on the lathe. I'm going to take this part, I'm going to mount it in the 4-jawed chuck. I'm going to center it using an indicator. I'm not going to get super precise because A, this piece isn't round, and B, it's got a lot of surface roughness. But I'm going to get close to the center, and I'm going to face one face nice and clean. That'll get me a flat surface, and that will be the thing I base all my subsequent steps on. Next, I'll turn it around on the lathe, and I will register it up against a set of parallels on the 4-jaw chuck. So I have just a tiny bit of stick out, but I know that it's flat and parallel to the lathe chuck, and I'll face the other side. At that point, I'll try and get to a thickness that is convenient for future steps. I'll measure it. Another purpose of those parallels, will allow me to get my calipers behind that face so I can do a good job of measuring the thickness relatively closely. Then I'm going to spot drill a little spot, then pilot drill, and then blow through the entire thickness with a 7/8 inch drill bit. That'll get me close to the interior diameter of the threading that I'm going to do later. Then I will take a boring bar and I will face that interior surface smooth, and I'll take a measurement to see what I ended up with. So I'll have a smooth cylindrical surface of some diameter, and it doesn't really matter at this stage what that diameter ends up being. And then finally, the last step on phase 1 on the lathe is I'm going to cut an interior profile that makes the threaded section a lot thinner than the actual thickness of the part. I'm shooting for only a 1/2 inch of actual threads on the inside of the part. The entire part is going to be closer to 1 inch in thickness. I wanted something fairly burly so that when I clamp it in a vise or I chuck it up in the lathe, there's something for the jaws to grab onto, but I only need a 1/2 inch of actual threads. The reason for that is I want my entire lap nut to blow entirely through these threads back and forth. I don't want to have, like a full inch of threads and I can only go halfway in. I want my lapping surface to be able to entirely go back and forth on this thread and clean it up. My instructor has advised me that that'll get me the best results possible. So I'm going to be cutting this interior channel so that the actual threaded part is only a 1/2 inch in length. So to do that, I'm going to take interior passes with a tool like this. I'm going to slide out on the cross slide and then out at a 45-degree angle with the compound to create an internal feature that gets me to the right thickness and gets me a 45-degree chamfer so that when I do thread on here, I'll have clearance to this 45-degree chamfer. Once that's done, and I have that interior surface on one side complete, then I'll go to phase 2. At phase 2, I'm going to be on the mill. So at that point, I'll have two nice parallel surfaces. So I can mount this in the mill vise, just floating in the air there, and it will be vertical because it's clamping on two machined parallel surfaces. That's where I'm going to go in vertically here with an end mill to cut out a little opening where my pinch bolt can go. And I'm going to do that with an end mill. I'll make a flat surface that the head of my pinch bolt can go. It'll look something like this, so that the entire pinch bolt will be hidden inside the exterior cylindrical surface of my tool. That'll keep things clean in case I ever want to spin this up again, that everything's on the inside. After I mill that flat, then I will spot and drill a hole for my pinch bolt, and I'll also ream it out so that it will have clearance for the non-threaded part of my pinch bolt. After that, while it's still mounted in the vise, I'm going to take an end mill and I'm going to shave off the top of this to a depth of about 1/8 of an inch. That'll give me a flat, this flat right here, which will allow me to subsequently hold the part in a vise securely. After that step's done, I will flip the part over, and since I have a nice flat milled surface there, I'll mount that on parallels, and I will do the other side of that recess and that other side of milling this flat. So then my part will be this general shape with two flats and with all the recess and through hole business ready for my tapped pinch bolt. Then I'm going to mount it flat in the mill vise like this, and that's where I will indicate off the center of my bored hole, and then I can use the digital readout on the mill to drill these two holes, which will allow for the entire assembly to compress equally around all three, in three lobes, to give me my lapping forces that I need later. And that'll finish phase 2. And from that point, we can go on to the bandsaw and then phase 3. Okay, so at this point, I will have a part that has a nice bored internal hole. It will have two holes drilled here, and it'll have some interior milled out surfaces here, and it'll be ready to take to the bandsaw. And what I'll do is I'll do 3 cuts on the bandsaw. First, I will just slide right through here, and that'll generate the gap that I need for closing my pinch bolt. And then once my bandsaw blade is in here, then I can go out to that hole and out to this hole to generate the 2 hinges that will allow the thing to compress around all 3 sides. After I've done that, then I can slide a shim into this gap, and then which will hold it and keep it from compressing, and put it back on the lathe for phase 3. In phase 3, I'm going to remount this part in the 4-jaw chuck. I can now indicate on either the outside or even or the inside of that bored hole. Doesn't have to be perfect, because what does need to be perfect is I will then be using a boring bar to go to the right internal diameter to start threading. So I'll run the boring bar through until I reach the minor diameter of an M25 by 1.5 millimeter thread. With that same boring bar, I will cut a 45-degree chamfer, which gives me a insert path to start threading. And then I'm going to cut threads. There's a tool that looks like a boring bar, but instead it holds a threading insert here, and you run that through over and over and over again to cut a precise M25 by 1.5 millimeter thread. We did it in this order on purpose, but we cut the bandsaw. Even though that's going to generate an interrupted cut, it'll end up with the threads themselves being as clean as possible. So it was important that we didn't do perfect threads and then screw them up with the bandsaw. We did the bandsaw operation first, and we're cutting clean, perfect threads after the fact. So that'll be a new operation for me, but one that I'm happy will generate the best results possible. After that's done, there will be the other side where I have not yet cut that recess that you saw in phase 1. I will do an interior chamfer, a cut to a depth on the cross slide, on the cross slide, and then slide out with the compound to generate that 45-degree clearance, so that we end up with a tool that is perfectly symmetrical left to right. And that should be it. Next, all I have to do is thread a pinch bolt in there. I'll be cutting an M6 by 1 thread, which should be straightforward, and that'll happen by hand, and then the tool will be ready to use. So let's see how it works.